All right, hey, welcome everybody. This is our lesson on sections 9.5 and 9.6, the angles of circles. This is going to follow a different order than our textbook and have a good reason for that. By the way, I'm outside. There's a lot of pollen in the air, so if your allergies are bad, I apologize. Hopefully you'll survive this video. So we've learned about chords and central angles here. But the chords and secants and tangents make angles, and those angles, their measures are completely determined based on where the vertex is in relation to the circle. So whether it's at the center of the circle, whether it's just on the circle, or it's inside or outside the circle. Okay, this box right here is most of all that you're going to need to know with all of these angles. Generally speaking, the measure of the angle equals the average of the intercepted arcs. That's what every textbook says. I have what I think is a better formula. It's this one. Don't use that one, use this one. Twice the measure of the angle equals the sum of the intercepted arcs. Okay? So use this one instead. So here's what we learned in section 9.4 with central angles. The measure of an intercepted arc equals the measure of an angle. So if we have this arc here is 56 degrees, this angle here is 56 degrees, and they're congruent measures. They're equal measures. If we consider the sides as chords or secants or diameters, look at what happens. We end up with another arc over here that's also equal to 56 degrees. So we have 56 degrees for the arcs, and this here. We could say that this angle here, 56, is the average of these arcs, 56 plus 56. Or we could say this, double the measure of the angle, 2 times 56, equals 56 plus 56. That's a silly thing to do if we're talking about central angles, but I hope that makes some sense, that yes, that can work. So over here in this other example, for solving for x, if this is 125 degrees, then these two arcs here are 55 and 55 degrees. They are these diameters cut off semicircles. So x is equal to the average of 55 plus 55. Or double the x is equal to 55 plus 55. Okay? Now what happens? If the vertex of the angle is not at the center of the circle, then it's no longer a central angle, so we have to treat it a little bit differently. We treat it like this up here. Consider what happens when we move the vertex away from the center, formed by chords and tangent. Okay, so what if it's here? The circle P, here's the center. The vertex is here, not at the center. Here's what we're going to do. This angle measure here, x degrees, double its measure is equal to the sum of the intercepted arcs. What arcs are intercepted? This one here, formed by these chords. All right? So double the measure of the angle, 2 times x equals 30 plus 55. Easy equation to solve. X is equal to 42.5 degrees. Repeat. The measure of this angle is equal to, 2 times the measure of this angle is equal to the sum of these two arcs. I'm going to take a shortcut. 2 times the measure of angle 1 equals 92. 40 plus 52. That's a simple equation to solve. 92 divided by 2 is 46 degrees. What if it asks you to solve for the arc instead? Same formula, double the measure of the angle, 2 times 45, equals 28 degrees plus x. So 90 minus 28 gets you 62. All right? Now, this one cuts off these arcs. Angle 1 here on question D cuts off these arcs. Well, we're given these arcs. What are we going to do about that? Well, we need to solve for this angle first. We're going to say that 2 times x is equal to 53 plus 47, plus 41 rather. So we get that x is equal to 47 degrees. That's not the answer to the question. That's the measure of this angle. We need this one. So what do? There's supplements. 180 minus 47 is 133 degrees. So when the vertex is inside the circle, double the measure of the angle equals the sum of the arcs. That is the lesson. We continue. What if the vertex keeps moving further away from the center of the circle until it is off of the circle? I'm sorry, not off the circle, that it's on the circle. When that happens, when it's formed by chords or secants, it's called an inscribed angle. That is has a special definition. We'll have a couple of other special things that we'll talk about with that. But I want you to consider this. This angle here, 61 degrees, cuts off how many arcs? Well, one, arc TU. The arc that would be here is equal to 0. At point S, there's no arc there. It's equal to 0. So still consider this. Double the measure of the angle equals the sum of the one arc that it cuts off. So 2 times the measure of 61 degrees is equal to TU, x in this case. So the measure of angle TU is 122 degrees. Repeat. Angle A here cuts off this one arc. When does that happen? When there's an inscribed angle, when the vertex of the angle is on the circle. So double the measure of the angle equals the sum of the arc, or in this case, the one arc. 2 times A equals 116. 16 is equal, or angle A is equal to 58 degrees. Question G, we have a little bit of work to do here. We're trying to figure out the measure of angle SVT. We need arc ST for that. That is the one arc that is cut off by angle SVT. We don't know its length, but we do know this arc. We don't know arc VU. Go to VU. We know arc SV. Oh, but VU has 51 degrees right there. So arc VU is double the measure of 51, 102. Now, the whole circle is 360 degrees, 360 minus 150, 102, 39. ST is equal to 84. Double the measure of the angle equals the arc, 42 degrees. Question H gives us a slightly different situation here. This is now a tangent. So part of the angle is not inside the circle, so this is no longer considered an inscribed angle. But because the vertex is on the circle, the same rule applies. Double the measure of the angle equals the sum of the intercepted arcs. There's only one arc, so it's not an inscribed angle. But double the angle equals the sum of the arcs. Half of 168 is 84. See if you can figure out then questions H, I, and J. You should have gotten 148 for H, 110 for I. These two are just simply inscribed angles, angles A and angle B. Angle C, you can either use this triangle here in the middle, or I could solve for X as 84 degrees. X and C are supplementary. Could have done either one of those. Now, inscribed angles happen so frequently that they have some of their own rules. So here, number one, the corollaries there are. If two inscribed angles intercept the same arc, then the angles are equal. Check this out. If measure of angle AB is 120 degrees, angle 1 cuts off arc AB. Angle 2 also cuts off arc AB. If they cut off the same arc, then angle 1 and angle 2 have to be what? Equal. They have to have equal measures. They're both equal to 60 degrees. That will provide for you some shortcuts at some different points in time. If they cut off the same arc, they're equal angles. Number 2, an angle inscribed in a semicircle is a right angle. Why? Because it cuts off 180 degrees. Think about it. If CE here is a diameter, then this arc here is 180 degrees. Okay? If that's 180 degrees, then this angle that is inscribed in this semicircle, this angle chops off 180 degrees. Half of the arc is equal to, my video chopped off for just a second. Hopefully this is where I was. The angle cuts off the semicircle, cuts off a 180 degree arc, so double the angle equals the arc. Semicircle, we get a 90 degree angle. Okay? The other case here, look for diameters. If you see diameters with angles that are on the circle, chances are they're right angles. Okay? We'll have right triangles as well. If a quadrilateral is inscribed in a circle, then its opposite angles, when inscribing the circle means the vertices are on the angles, or on the circle rather, then the opposite angles are supplementary. So check this out. If 360 degrees is the entire circle, angle 4 right here chops off this arc. Angle 5 chops off, well, the rest of the circle. If those two angles together chop off the entire circle, then they're double the angles equals the arc, so each angle then has to be supplementary. Or sorry, each pair has to be supplementary. 4 and 5 are supplementary. If I were to name these 7 and 8 over here, well, angles 7 and 8 are supplements too. So opposite angles of a quadrilateral that is inscribed in a circle are always supplementary. Okay, last piece of this puzzle. So what if we move the vertex of the angles? We talked about it being at the center, we talked about it being inside, we talked about it being on an inscribed angle. If we keep going, if it's on the outside, this is where it's slightly different. Then the angle, it's made up of secants and tangents. The measure of the angle equals half the difference of the arcs. When we talk about difference, it's always going to be the big arc minus the little arc, but it's the difference of the intercepted arcs. Don't use that formula, use this one. Twice the measure of the angle equals the difference of the intercepted arcs. When we talk difference, always use big minus little. So example 1, or example K over here, here is this angle. Angle 1 here is the vertex is outside the circle. It cuts off these two arcs, 40 and 80, so twice the measure of the angle equals 80 minus 40. 2 times measure angle equals 40, the angle equals 20. I'll do 2 more with you here. Measure angle 2. Z is the vertex, it's outside. We have these two arcs, 160 and 80. Twice the measure of the angle equals 160 minus 80. Twice the measure of angle equals 80. It's 40. Simple enough. This one's formed by 2 tangents. Notice it doesn't give us the other arc. Why not? Well, this is 220 degrees. There's only 2 arcs here. We have arc, the major arc of A something D, and then we have arc AD here. Well, then that other arc has to be 140. Okay? Double the measure of the angle equals 210 minus 140. 210 minus 140 is 80. Half of 80 is 40. See if you can figure out the next one. You should have said double the angle equals the big arc minus the little arc. You get 30. Check this one out. We're trying to find the measure of ln. Let it be x. If ln is x, if arc ln is x, what's the major arc? 360 minus x. Write an equation from that and see if you can solve it. Double the measure of the angle. 2 times 50 is 100 equals 360 minus x, the big arc minus the little arc. Use algebra, solve it. Same thing over here. The big arc here is x. We're trying to solve for that. The little arc in this case would then be 360 minus x. This happens when there's tangents. Double the angle equals x, big arc minus 360 minus x. Solve the equation. Okay? All right. That is a combination of sections 5 and 6. If you have questions about this, come see me. I'd be glad to help you. Get some rest. Jat Luggers. Bye.